we've been looking at different strategies in class for multiplying decimals, and one of the strategies we talked about was how to use the algorithm with decimals and better show our understanding of place values. So here we have two decimals, 7 and 6/10, times 3 1/2, or 3 5/10. So how can we multiply these two decimals together using the standard algorithm, but also showing our place value clearly? We know that in 7 and 6/10 there is a whole number, so 7, which we can also show with a decimal. Oops. And then we also have 6/10. So if we were to break these apart and show their place value, we show them like this. In our second number, 3 1/2, we know we have one whole number, which is 3 in the ones place. And then we also have a 5 in our tens place, which again is a half. We can use this information to help us track our steps as we work through the algorithm. So our first step would be to start in our furthest right place value here, which would be our tenths place, 5/10. And we're going to multiply up, so times 6/10. 5 times 6 would give us 30 if we were using regular whole numbers. In this case, however, we're dealing with tenths. So we can show this a number of ways. First, we know again that this is 30, but how do we figure out the place value of our answer? If we were to shade these two separate decimals onto a grid, we would shade them like this. 5/10. Not perfect nor pretty. And then we could then take our 6/10 and shade in the opposite direction. So let's put a blue into here. 1/10, 2/10, 3, 4, 5, 6. The area where both colors overlap is going to be the answer to our question of place value. So if I go ahead and put a box around this array, I have a 5 by 6. 5 times 6, again, we know is 30, but the size of our pieces gives us our place value. We know here that we're dealing with hundredths. So when I rewrite this answer, it's going to be 30 hundredths. I'm going to keep my place values lined up and my decimals together. Our next step would be to multiply our 5/10 by 7. So again, we can show our steps on the side. We know that 5 times 7 is 35. In this case, because we're dealing with tenths, we could skip count by 5/10. 7 times, just to check our work. We could draw this in a picture. We could do a number of things to show how this answer would look in terms of place value. If I go ahead and clone this number 7 times, 5, 6, 7, and group them together into whole numbers, we have 1 whole, 2, 3, and I forgot my 7th number, so let's pull one more out of here. So we have 3 wholes, 1, 2, with a half left over. So by using repeated addition, I can make sure my place value is sound and together we have 3 1/2. Now that we're done working with our 5/10, we're going to come over here and use our 3 as a starting point. So our next step would be to multiply the number 3 by 6/10. Again, we know that 3 times 6 will give us 18. And if we use the same skip counting reasoning here to show this, if we skip counted by 6/10 3 times and did the addition, I'm going to go ahead and do that over here. So we need this 3 times, and add these together just to show my understanding of my work. I know here I would end up with 8 in the tens place and 1 whole. So this would be 1 and 8/10. The final step in this problem before I put my multiplication together will be to multiply my 3 times 7. So 3 times 7. And we're working with whole numbers, so we know our answer here is 21, and we want to line up that answer using our place value. And any whole number, remember we can place a decimal afterwards, because even though it doesn't necessarily have to be there if we were working with money, we would put it in, and it helps us line up our place value, make sure that we're in the right place. So if we were to go ahead and add our products together, we will find the answer to our multiplication problem. I'm actually going to in our hundredths place, we have zeros. So we're going to add straight down and find that there's nothing in our hundredths place. Here we have 3/10 plus 5/10, which would give us 8/10 plus another 8/10, which means we've created a whole with 6/10 left over here. 1 plus 3 is 4, add 2 more and we have 6. And then we have a 2 in our tenths place. So our answer to this problem is 26 and 60 hundredths.